Hey guys, welcome back to geometry. We're going to continue with our transformations, but we are going to focus on reflections in this video. So go ahead and hit pause to copy down what's on the screen. Okay, welcome back. So when talking about reflection, a reflection is a transformation that flips an image over a line. And that line that we're reflecting our image over is called the line of reflection. So you'll see that here. Okay. Another important thing to note about reflections is that the pre-image and the image, aka your before and after, are equidistant from the line of reflection, are equidistant from the line of reflection. And I just shorthanded that as LOR. So LOR means line of reflection, and I'm going to just draw a little arrow. So AKA this. Okay. Now before we go on, I think we should define equidistant because that might be a new word for some of us. So equidistant, what do you think that means? Okay. So if we're looking at the word equidistant, the definition is actually in the word itself. So we've got equi right here, which basically means equal. And then we've got distant over here, which is distance. So equidistant means equal distance. So your before and after image are an equal distance away from your line of reflection. Let's take a look at an example. So in example 1, we have the point E, which is at 1, 3, and I'm being asked to reflect it over the line y equals -1. So y equals -1, this is going to be our line of reflection. Now, if you guys remember from a previous video, when I've got an equation in y equals form, that means I'm going to have a horizontal line at the y value of -1. So -1 is just one below our x-axis. And here we go. This is our line of reflection. This is our line y equals -1, aka your line of reflection, your LOR. So I'm being asked to reflect the point 1, 3 over that dotted red line right there. And it's really easy just to reflect the point. Remember, your before and after image are equal distance from that red line. So we can really just count. So this point is 1, 2, 3, 4 units away from your red dotted line. So that just means I need to count 4 points on the other side. 1, 2, 3, 4. And your new dot is going to be there. Your x value stays the same because I didn't move left or right. I just changed the y. And it looks like it's at 1, 2, 3, 4, -5. So your new point is at 1, -5. And that's where E prime is at. Remember, this is called your image. And our original, that one was called our pre-image. Okay. All right, let's try another example. Go ahead and copy this down in your notebooks, hit pause in the video, and try this problem on your own. Okay, welcome back. Okay, so in example 2, we're being asked to reflect the point D, which is at -3, 1 over the line x equals 2. So again, here is our line of reflection. And if I've got an equation of a line that starts with x equals, that means I'm going to have a vertical line at the x value of 2. So here's my x value of 2, which means my line of reflection is located here. This dotted red line is at x equals 2. Okay. And then in a similar fashion, I can just count the number of jumps until I get to that dotted line. So I'm going to go over 1, 2, 3, 4, 5. So D was 5 away from 2. And I can also see that, right? If I'm looking at the x value of -3 and the x value of 2, those two numbers are 5 units away from each other. So if I'm trying to figure out what my new x value is going to be, well, I know I'm starting at the x value of 2, and I know that my new x value has to be 5 units away on the other side. So if I'm moving to the right, that means I'm adding 5. So 2 plus 5 is going to give us 7. Let's check. 1, 2, 3, 4, 5. Here's my new point, and it's at 1, 2, 3, 4, 5, 6, 7. It is at 7, comma 1. So that is where D prime is. That is our new coordinate. We've reflected it over the line x equals 2. Thanks for watching.